56. If for a process delta H and delta S respectively are minus 20 kilojoules per mole and 200 joules per Kelvin per mole, then at what temperature reaction will be spontaneous? The options are 100 Kelvin, the next is 120 Kelvin, the next is 90 Kelvin, or all of these. Students, for this question, we need to know the relation between delta G, delta H and delta S. I'm writing the relation delta G is equals to delta H minus T delta S. Students, in this question, we are given with a spontaneous reaction. And for a spontaneous reaction, the value of delta G is less than 0. That means the value of delta G is negative. So let's see at what temperature the value of delta G is negative, and we are given with the value of delta H and delta S. So let's see. The value of delta H has a negative sign and the value of delta S has a positive sign. So students, it is very clear that when the value of delta H is negative and the value of delta S is positive, no matter what the temperature is, the value of delta G will be negative. As a result, we can say that at 100 Kelvin, at 120 Kelvin or at 90 Kelvin, the reaction will be spontaneous. So the correct answer for this question is option number 4. Moving to next question, which is 57. Internal energy change of a process is equal to. The options are isobaric work, adiabatic work, isothermal work, all of these. So students, according to first law of thermodynamics, the change in internal energy, which is delta U, is equals to work done plus heat change. Under adiabatic conditions, we have already discussed adiabatic conditions. The value of Q is equals to 0. As a result, we can say that change in internal energy is equals to adiabatic work. That means the correct answer for this question is option number 2. Moving to next question, which is 58. Reaction for which difference of delta H and delta U is maximum is. The options are Ti I4 gaseous gives Ti solid plus 2I2 gaseous. The next is NiCO whole 4 gaseous gives Ni solid plus 4CO gaseous. Next is 2NH3 gaseous gives N2 gaseous plus 3H2 gaseous. The next is PCl5 gaseous gives PCl3 gaseous plus Cl2 gaseous. Students, for this question we need to know the relation between delta H and delta U. I'm writing it. Delta H is equals to delta U plus delta Ng RT, or we can say that delta H minus delta U is equals to delta Ng RT. So students, it is very clear that greater the positive value of delta Ng, larger is the difference between delta H and delta U. So now we have to identify that among the given reactions, which reaction has the higher positive value of delta Ng. Starting with option number 1. In this case, delta Ng is equals to 2 minus 1, which is equals to 1. Moving to next, the value of delta Ng is equals to 4 minus 1, which is equals to 3. Moving to next option, the value of delta Ng is equals to 4 minus 2, which is equals to 2. Moving to last option, the value of delta Ng is equals to 2 minus 1, that is equals to 1. So it is very clear that among the given options, the highest positive value of delta Ng is in case of option number 2. That means the difference of delta H and delta U is maximum in the second reaction. That means the correct answer for this question is option number 2. Moving to next question, which is 59. If a gas X2 if uses 4 times slower than H2, then molar mass of X2 is. The options are 8 gram per mole, 32 gram per mole, 16 gram per mole, or 48 gram per mole. Let's solve the question, students. Students, as we have already discussed that rate of diffusion or effusion is inversely proportional to the square root of molecular masses. So, rate of effusion of X2 upon rate of effusion of H2 is equals to under root of molecular mass of H2 upon molecular mass of X2. Since we are already given that rate of effusion of X2 is 4 times slower than that of H2. So if rate of effusion of X2 is 1, then the rate of effusion of H2 will be 4, which is equals to under root of 2 upon molecular mass of X2. Taking square on both the sides, 1 upon 16 is equals to 2 upon mass of X2, which ultimately gives molecular mass of X2 as 16 into 2 is equals to 32 gram per mole. That means the correct answer for this question is option number 2. Moving to next question, which is 60. Compressibility factor Z of helium gas at low pressure and at 273 Kelvin is. The options are 1 upon 2, 1 plus Pb upon RT, 1 plus B upon RT, or 1 minus A upon Vm RT. So students, for 1 mole, the van der Waals equation is P plus A upon V square, V minus B is equals to RT. For helium, the value of A upon V square is 0. So van der Waals equation becomes P V minus B is equals to RT. Let's multiply P in the bracket. PV minus PB is equals to RT. On dividing the equation by RT, we get PV upon RT minus PB upon RT is equals to RT upon RT, which is equals to PV upon RT minus PB upon RT is equals to 1. Students, as we are aware that PV upon RT is equals to Z, so Z is equals to 1 plus PB upon RT. That means the correct answer for this question is option number 2. Moving to next question, which is 61.